Good morning, sir. We'll start the session in 5 minutes, sir.
Yes, good morning, ma'am. We'll start.
Shall we start the session, sir?
Yes, ma'am. Yes, ma'am.
Okay, sir. Good morning, one and all. I, Meghna Gundaboina, Assistant Professor, Triply Department, Vardhman College of Engineering. I warmly welcome you all for the Day 4, Session 1 FDP on applications of power electronic converters to power and energy systems. Uh, the main aim of this FDP is to analyze and evaluate the numerous emerging technologies and inventions and to explore the impacts of emerging developments on power electronic converters. So, our today's keynote speaker is Dr. K. Perumal Garu. I take this privilege to introduce our today's keynote speaker, Dr. K. Perumal Garu. Dr. K. Perumal Garu received the BE degree in Electrical and Electronics Engineering from Anna University in 2006 and MTech degree in High Voltage Engineering from JNTU Kakinada in 2012 and the PhD degree from Pondicherry Central University, Pondicherry in 2020. And currently he is working as an associate professor in Department of Electrical and Electronics Engineering, Vardhaman College of Engineering, Hyderabad. He has 14 years of teaching, research, and industry experience. He has presented over 14 research articles in national and international conferences in India and abroad and has published 32 research articles in national and international journals. He filed a patent titled Design and Development of Shadow Free Efficient Solar PV Tree, Solar Powered Peltier Icebox, IEMG Power Bank. His research interests include renewable energy optimization, hybrid renewable energy systems, and energy management system and energy storage systems. He has been acting as an editorial board member and a reviewer for various reputed journals such as IEEE and IET. Thank you for having you here, sir. Now it's over to you, sir.
Thank you. Thank you very much for your right. I'm welcoming all of you for this uh, sharing events. First, I'm sharing my slides.
Sir. Yes, sir, it is visible.
Thank you. Today, I'm going to discuss with you the microgrid design using the advanced simulation tools. Our maybe this workshop is a theme is a micro power electronics based converters. This comes under the application of the power electronics converters. Power electronics converter having the many proficiencies and many researchers expecting many important features in the power converters. So why? Because means the microgrid having that much a wide span of the characteristics. So this is also apt for this theme related to this workshop. Here mainly we are concentrating about the how on microgrid or distributing generations we can simulate with the available advanced tools. Today my presentation flow this one only. We'll start the renewable energy systems and what are the position of the renewable energy investment in the various countries and continent levels. After that, electricity demand is a day by day our electricity demand is increasing, and that increasing energy crisis how to contribute our renewable energies. So that uh, in fact and that concept also we are going to discuss today. And then many renewable resources we hear, and that is also successfully implemented. So, what is the pros and cons of the each renewable resources? When that renewable resources is working in the alone, okay, that issues may be different. That issues and challenges differ. When the renewable resource is integrated to each other's means, it's a challenge is a completely different. So that point of view, the pros and cons of the each renewable systems we are going to discuss. After that, the main area of the this presentation, the microgrid design, and what are the challenges. Um, that things we are going to discuss with the help of the advanced simulation tools. Then some case studies also we are going to discuss in the end of this presentations. is a realistic case studies based on the geographical resources availability and technology availability of our Indian nations. So which type of the microgrid system is affectable for us? So that is also we are going to discuss in the end of this presentation. Um, this is the one of the resources um, taken from the British Business Energy magazines. So this slides is clearly expressed about what are the renewable energy important in the worldwide. So this is a top 10 dominated renewable energy countries I listed here as per its policy concerns, as per implementation concerns, and it's a flexibility for the different weather concerns we are seeing here. So according that, we are in the third positions. In India is a word third positions we are placed. So here the concentrated dot is indicating the investment of the different countries. In India, we have the reasonable weather. And that means nearly 6 months is a very hot, nearly 6 months is a very cool, and the wind potential also possible. So we are having the provision to use the wind as well as the solar also. Apart from that, due to the agriculture background of our nation, we can have the chance to utilize the biomass also. So that point of view, we are obtaining the third positions. It's not only this is a resource available to our countries. It's a policy also one of the important things. So what are the policies that different countries are using, and what is the policy we are our countries are using? What importance, what flexibility the government given for renewable resources implementations? So many factors are inherent here to attain these third positions. Even though the many countries is the well known the developed countries and the economically grown countries also, it's not it is behind of us. Why? Because the resource unavailability there. If you see the Germany is nearly 6 months is the cold weather. We can't use the solar there at all. And at the same time, is a wind potential also is very high. There is also that dynamics is also is overfitting to develop the energy generations. So that point of view, um, this classification chart is given the information for us. So this is the electricity demand increasing as well as the contribution of the renewable energies here. So see here the y-axis is mentioning as the terawatt hours and energy demand and the energy generation process between the year of 2019 to 25. So that we are representing here. Um, in these slides, it's giving the some more additional information about the renewable energy penetrations. So many renewable energy is possible. Solar, wind, tidal, hydro, pico hydro, and flywheel arrangement. That means any water flow available means there is also possibility to generate the electricity. Geothermal also we can use it, and biomass also we can use it. So what is the provisions? What is the supportive nature to utilize that resource is a matter here. So at the same times, our demand also increasing rapidly. In India, concerns is still nearly 80,000 of villages not connected to the grid supply. Why? Because it's a difficult to the terrain implementation. That means it's a route of the our transmission line and distribution factors. The hill areas is not at all possible to connect in the grid system. Why? Because the very attitude of that. At the same time, is some of the island also is takes some much some of the huge expensive to implement that. So that point of view, what is the scope to give the energization of that villages means is renewables only. So see here is a worldwide what is the demand and what is the renewable energy contribution means almost the same. So what is the demand we have? That all the demand we can fulfill with the renewable itself. That possibility we have. So remaining bar charts, it's expressing the what is the different penetration of the country resources. For seeing the China, that the demand is very high. but them contribution the renewable nature point of view, it is not up to the marks. If United States you see, there is a per unit energy consumption is very very high. Okay, even though that energy consumption they're ready to fulfill with the renewable resources. So that point of view, you see our country, so our demand is very high. Almost the renewable penetrations and that contribution is nearly 60 to 70% only can fulfill. What about the remaining things? It is a conventional energy only, because already we have some certain energy providing setups, and that setups based on the coals, based on the fossil fuels. So we can't change completely. We can't utilize that service is at one night. So slightly we will increasing our renewable contribution. We can shut down the all the conventional energy. So that motto is based only our countries is putting the step in forward. So pros and cons. So main and this presentations deals about the integration of the renewable resources. If you want consumers, he is a residential consumers, he may interested to install the renewable energy for his energy development means he first prepare as a wind solar. If you a wind potential area means you can go for the vertical type of the wind turbine. The solar it having some limitation. At the same time, is the wind turbine also having some limitations. Solar is a day only, daytime only it can generate the power. So nighttime we can't use it. If you alternatively the wind potential, the wind contribution is very less in the nighttime, and the daytime its contribution is not that much level. So is it possible to combine both? If it possible to combine both means we can get it the uninterrupted power supply to that customers. So such a pair we want to call, we want to found. That is the main motto for this microgrid design. That is the main challenge also. So what is a which two renewable resource we can integrate? And what is a complementary pair of each another? Generally, the solar and wind is a complementary pair. If you go for the hill area wind and hydro also is a complementary pair. If we go for the any riverside base, river basis means there is also the flow of water potential we can use it, as well as the wind potential we can use it. It's a cool area is we can go for the wind. So like that is our job at our geography nature. Some resources is dominating, some resources is not dominating. So we need the uninterrupted power supply means which pair we can use it. Otherwise, that is a multiple energy resources combinations we need. So that combination we want to create means what are the cons and pros on each and every renewable resources we should know. So that point of view, we can get the information here. The infinitive source of the energy supply is possible from the solar and wind geothermal. But what is the drawback with this solar and wind means? It's uncertainty. So due to the global warming, we can't utilize this. Otherwise, we can't predict accurately when is a solar energy is possible, when is a wind energy is possible, how much is potential is we can use it. So that prediction is not accurate. Why? Because uncertainty for due to the global warmings and melting of the ice fields like that. So this uncertainty, how we can handle, that is also one of the challenge to microgrid design. Then what is the additional advantages for this solar and wind means it is a no pollutions. The sustainable goal, it's a environmental friendly technology is needed. So that point of view, solar and wind is the it's putting the vital role here. If you see the wind and solar through the year is possible, and it is a the source is a infinity, we can use it unlimited. So there is a no fuel cost and running cost. So that point of view, the solar and wind is a dominated. And standby losses, if you hydropower you see, generally hydropowers we are developed from the dam. The water opening, that means the gate walls are opening for the irrigation purpose, agriculture purpose. Meanwhile, we putting our energy generation technologies and developing the power. So that is the already purpose is differ, and we are utilizing is a effective manner. That is the additional benefit from the hydropower. And construction wise, it's a little cheaper than the normal thermal power plant. If you see the bioenergy also, it is having its own merits. That means a huge energy we can get it. The peak energy we can make it. We can manage with the help of the geothermal energies. And bioenergy, biomass based energy generation means it is the way to the disposal of the waste from the agricultural, from the animals, because some of the countries, some of the cities are having the problem how to dispose this biomasses, bio wastes. Okay, if with that wastage we are utilizing the effective manner, and we generate the power means it's appreciating. So these are the uh, main pros of the renewable energies. And we we narrow down the what is that cons and each and every renewable resources based power generations. For example, the solar, that means is a solar irradiation is very high, and that is the when the sunrise and the sunset. So that duration only energy generation is possible. That point of view, um, that all the energy is possible to utilize to our consumers means is not. Why? Because there is a mismatch is happen. Our demand is after 6 only is possible. That means if you observe the day profile of the any residential load or any industrial load in our country, the peak demand is raised in the evening. That means nearly 6 p.m. to the 10 p.m. So that is a peak load. So in that time, solar energy we can't use directly. But if we interest to use the solar energy means is a backup system is needed. That is a battery energy storage systems. Otherwise, any energy storage system. That means energy storage system is needed when energies we are using in the unavailability of the resources. If you going for the wind, it's a cons is the um, that is a pollutions. At the same time, is occupying the more landscape in the our environment. We can't use this type of wind turbine in the all over of the part of the countries. So very few places only we can use it. At the same time, that areas is polluted with the noise, and that type of issues will come. um, because the megawatt generations and 0.5 megawatt generations are continuously rotating. Some threat is there. So that type of drawback we can face it with this wind resources. Is many agriculture peoples are refused. Otherwise, they are against to install this wind turbine in the own land. Otherwise, the occupied lands. So that is also issues there. If we come to the hydro, is a cost is the building cost is high, and the flood durations, our energy generations will disturb, and uncertainties of the rains and monsoons and agriculture, the main objective of the agriculture and water opening. This is also it's affect our power generation process. If the biomass concerns is a burning of the biomass, that means any residential, any residuals we want to burn, from that only that energy we can use it for the energy generation. So here that burning, it is again that emitting some carbon particles to the atmosphere, but in the form of the less comparatively the thermal power plant. If a thermal power plant is producing the nearly is 1 ton, um, 1 ton of the one particular energy generations means this biomass is in the terms of the 100 grams, like that only it can produce the carbon content to the atmosphere. This is one of the low carbon emitted based energy generations. The geothermal, again the expensive setup, and that it is providing some hazard to the residential peoples also. Because the geothermal is drilling the earth. So it is not safe, but we need the more energies. We want to handle the all the peoples with the continuous power supply. So there is a one chance is that from the thermal to the energy generation, that purpose we are depending on the geothermal also. So this is the main design factors related to the renewable energy system design. Renewable energy system in India concerns many people they hesitate to the follow. The many reason is there. Is what is the reason? So one of the reason means is a cost, the implementation cost. That is one of the factors. So we should when during the microgrid design, otherwise renewable energy designs, we should consider this is one of the important factors. That means the cost, what is the investment and what is the replacement cost. That amount when it's a get back again. So that means a payback period. So the complete economic analysis we should know. If that economic analysis satisfy with your constraints means we can implement that. If you suppose the economic constraints is not fulfilled, your constraints mean uh, your interest means we want to find out the some other configuration of the renewable resources. If your solar is not fulfilling your economical constraints means it's a wind is possible or not. If wind alone is not possible means we can make it the combinations of the solar and wind. That means integrated setup. That is called a hybrid setup. At the same time, is a renewable energies because the renewable energies depends on the renewable resources availability. That means resource itself uncertainty is there. Our fulfillment based on this uncertainty resources means how we get it the quality power supply. So that is also the peoples are thinking and hesitating to follow that. Apart from all those things, what is the policy we have? The government policies. What is a subsidy? What is the motivations? What is the subsidies the government they provide to us to implement the renewable resources? Okay, so here main thing the energy conservation as well as the effective utility of the resources. So that is the main challenges here. So here we are seeing nearly 10 factors, all the factors surrounding that two objectives only. Our solar based energy is a very precious one. That means it's a solar panel, the energy conversion efficiency itself maximum 23 percentage only. Its efficiency started from the 13 percentage. After that, the continuous research and development, we reached our efficiency the 23 percentage now. So the energy conservation is a efficiency is a 23 percentage only. That energy we are using our outdated heating load and cooling load means what logic behind that? The precious energy we are using our consumption of a component that is outdated is consuming the more energy. So there is a no logic to the effective utilizations. So we want to change our loads parameter also. So then only this precious energy we can use it in the effective manner. So that is also one of the challenge in the microgrid design. Now is a microgrid. We are saying the microgrid are distributing and generations. The many type of microgrids are available. DC microgrid you are here, AC microgrid you are here, and a hybrid microgrid you are here. That means um, we are ready to generate the energy in the load side itself. That means the distributed side itself. So there is a source is ready and generation is ready and utilization also that site itself we are make it to the design. So in this objectives, what are the component is needed means is the energy generated component is needed and load component is needed. Then energy and load, what type of energy is producing? That means AC type of energy or DC type of energies. Okay, if your load is a AC and the generation is a DC means is a conversion technique is needed. That means that the DC you want to convert into the AC, so inverter is needed. Okay, if you windmill Windmills producing the AC. Our load is the AC. Meanwhile, you want to store it means you want to convert into the DC. Then battery storage is possible. Battery you store it the battery, then we can use it. So that type of cycle, that means energy conversion equipment, that is called your power electronics devices. Okay, that is also important. So based on the application, based on the component, the microgrid definition is a very wide one. We can find out the microgrid definition is a that means many definitions we can see. So as per my state of research on this area, the microgrid means it's a need some power control devices and some energy generation devices and energy utility component. That's all. The energy storage device is the optional one. If energy storage device is there means, okay, it's we can say that is a smart grid. We can, if it, that complete system, it's a solving is the problem itself means, okay, that complete system is a continuously monitoring any problem occur, okay, that issues is solved the system itself means we can call it as a smart grid. Is a distribution generations means is a storage system is must. Why? Because the microgrid, the energy we can use directly to our load. That energy we can use or store and use also provision is there. So the microgrid with the storage system also one of the type. Microgrid without the storage system also one of the type. So what is mean by the hybrid renewable energy system? That means it's a combinations. You know that is standalone system. That means a standalone system means there is a no grid continuity. That means grid terminal is not available. That means off grid system. The off grid system, suppose you are designing with a complete solar means is a oversizing is possible. That means you want to invest the more, yeah, more investment on with that. Why? Because due to our climate, due to our uncertainty of the energy, uncertainty of the resources. Okay, so some month is a more demand is some more radiation is possible. Some month is a less radiation is possible, but your load is almost a little variations only. Okay, if your resource are more availability means you can fulfill your load demand easily. But the resource availability is very less. But your demand is almost a constant is we are maintaining means. So how you fulfill it? So in that time, the oversizing of the component is happen. So that is the additional it takes the additional investment. So we feel it a very uh, luxury setup. So if you this type of issues happen means we can go for the multiple renewable resources, the solar wind biomass, solar with battery, solar with genset, that means biogenset. So this configuration is easily meet out our demand continuously and effective manner. That is called as optimization configuration or optimization component of the devices. So that is the main criteria here. So the hybrid renewable energy system means it consists of two or more energy sources. At least one is the renewable. That's why this is a hybrid renewable energy system. It's integrated with the power control equipment, and the option is the storage system. So this is the generalized definition for the microgrid. Done. Now, what are the challenges we are going to face when design one microgrid? So it's a simple you may consider in our home itself. So what is our load demand? That load demand, when is the peak happen? What is the per day demand? That means one day how much demand is need for me. Okay, on in the one day what is the peak demand? So this is one of the decision to decide our energy generators. That means is a which type of solar panels, what type of wind turbine, what is the range of that this thing. Then, if the solar panel and the wind turbine is capable to meet my demand is continuously or not? That is also one of the decision making question here. It's a need the battery bank or not. Is a battery bank means which type of anatomy we can use it. What is the base voltage level? What is the amps levels? And what is the backup time is needed? Okay, is some cases is a emergency the genset they may using for industrial or hospital some the continuous industrial process they're using the genset to avoid the uninterruption of the process. So fuel price. So when the fuel prices changes, what is the energy generations and what is the contributions, or is my demand fulfillment, how that everything will disturb. So that is also one of the decision making questions. Then what is how we operate that system during the daytime, during the night time. Otherwise, is a energy first priority we give to the primary road. Otherwise, we store the energy and utilize that. That means if you generate the energy directly used to your demand means that the system is called load following. That means always our generator giving the preference to the our load. So that strategies we have in the microgrid system, the load following strategies available. Is a another strategy. Another strategy means we are ensuring our backup first. Then any excess power, any after the fulfillment of the backup power, that power we can use it for our load. That is called cycle charging. So cycle charging strategies available, load following strategies available. The cycle charging strategies means um, it takes the more amount of the investment in the storage system itself. Why? Because the all the storage system it having some lifespan. At the same time, it having some operating span also. Some 500 operating cycles we can use it charging, decharging, charging, decharging like that. 500 operating cycle means after 500 operating cycles that energy storage system we want to replace it. So that is additional cost, replacement cost. If you load following strategies means um, your system to have the oversizing component. That means the exact designing of the exact design, exact sizing is the issues there. So oversizing also issues and optimal cost also issue for us. Okay, so here in the microgrid design, we are considering the both. We want to avoid the oversizing of our component. At the same time, is a reasonable investment we want to find it for the uninterrupted power supply. So related these objectives, these are the questions, these are the decision we want to take as a designer point of the microcontroller, micro grids. So related this, any advanced simulation tools is helping or not. So see this blocks. Um, what are the provisions we are expecting from one simulation tools? All those things is listed in the horizontal. Is what are the softwares is available? What are the software tools, advanced tools are available to simulate these things? We can see in the verticals. So here, this all those things is a commercial software and somewhat is a free software, open source software also available here. So what are the provision we are expecting generally? So now our objective to design on the optimum microgrid components. Otherwise, we can say that it is the optimal configuration of the microgrid element. That means the solar, what is the range, wind, what is the range, the converter range, and what is the complete cost, what is the performance of the complete system. So this thing is the main challenges for one microgrid designer. So what we are expecting generally, any simulation software, any optimization software is possible. The simulation and optimization is both is a different. The simulation in the sense, you giving the many input, that means the n type of input you are given with the help of the n type of input, all the set of the output you can get it. Optimization means you given the certain input, out of the certain input, which output is a preferable, which output is a recommended for the implementation. because that optimization is decided by the constraints, user constraints, system constraint. The simulation is not having that type of constraints. It is having the parameters only. If we so simulations is possible or include optimization also possible. So that type of tools we want to pick it. Then is it any tools is helping for the photovoltaic cell or wind energies or biomass energies, because the many tools is possible for the particular resources only. If you take it as a solar, the PV syst is there, PV watts is there. Um, that that means it's a only one source based simulations. Many tools are available. When the combinations of many tools means it's very peculiar tools only available. So all the tools we are, I'll give some hint about that what is the benefit of each and every tools. So the above sites, photovoltaic, wind turbine, biomass, battery storage, residential modeling, that means a residential type of uh, model, um, industrial models, district modelings, regional modeling, because the residential district regional modelings, it is the scale of the energy generation, correct? So scale of the energy generation means generally the residential modeling means per day demand maximum 10 units. If your district means it is a megawatt, it is a regional means is a hundreds of the megawatt, correct? So the small scale simulation is possible, large scale simulation is possible. So that is the these parameters. Then what is the finance of that? Financing analysis is possible. That means economic analysis is possible. Performance analysis is possible. Is it that software is a free or cost? Okay, so it's a beginners can learn, otherwise it needs some trainings. It's advanced tools are beginners tools. So these are the listed, these are the provisions we are generally one designer expect. So here the many system, many tools are available. The first tool is the SAM tools. We can use the SAM tools for the microgrid design, and the SAM tools indicating there's a system advisory model. That is a system advisory model. Um, that means it will give the complete advice about the systems. That means economical advice and performance advice. If we generally this integration of renewable resources means we should follow the government norms, and that is the policy. That means if you consumer, he may produce the own energy in his rooftop. At the same time, he need some extra energy. Otherwise, he want to get it. He interested to buy the energy from the um, our distribution system. Also means we should sign it with some policy. That means a power purchasing policy or power purchasing agreement. Okay, the excess energy he may send back to the grid. Otherwise, whenever the scarcity is there, he may get the energy from the grid also. Okay, so that is the contract between the customers and our centralized grid system. So that type of analysis also possible in the SAM, that means system advisory models. And performance, that complete system performance we can analyze, and complete system economical nature also we can analyze. That means how much capital is in need, how much investment, what is the replacement cost. We call it as a lifespan cost. That is called NPC, net present cost. The net present cost means each component, the money having the present values, correct? So today's money and tomorrow money is both is a different. So how we can conclude this, fix it, this type of issues means is a NPC value we can use it. What is the investment? What is the investment interest rate minus of the depreciation level? So this combinedly, the all the three parameters is indicating the one values means that is called the NPC or life cycle cost. So that provision is available or not means it's a SAM it having that provision. Then second software is the CREAST. That is a CREST. It is the cost of renewable spreadsheet tool. Actually, the SAM and the CREST, many tools here. The many tools are available. The all the tools are introduced by the National Renewable Laboratory Canada. because the Canada is a that is a dominated country to simulate this type of integrated system, integrated renewable system. Uh, Initially, they are very good in the renewable system simulations. Now, them concentration on the integration of the renewable resources. So the mini tools is introduced for them only. So mini tools is designed by that people only. That is a National Renewable Energy Laboratory. We call it as a NREL. Okay, so that people's only is introduced this one. Here the CREST, that is the cost of renewable spreadsheet tools also they only implemented. Actually, this is a spreadsheet approach. Each and every year demand will calculate in the one spreadsheet. That values we can pick it into the next spreadsheet for the calculating the performance. That value will pick it for the next sheet for the performance measurement. Then PV watts. This is the particularly for the solar related simulations. That means the solar panel array related the simulations. Um, Actually, what is this PV watts means? It is the regional resource-based simulation software. The PV watts is recommended. It have some database. That is database is having the fast registered solar radiation data. Based on that radiation data, we can utilize that is for our microgrid design. So what is the benefit of this software means is a radiation. That means a radiation measurement. Generally, two type of and data measurement is possible. One is a satellite-based data measurement. Another one is the ground level data based and ground level based data measurement. Here, satellite-based data measurement is a good for the case of the some wide area design. That means regional uh, kind of the modelings is good for the satellite-based measuring unit. Some particular residential, particular industrial based design is need means, okay, we should measure the resource availability on the ground itself, on the site itself. If you're putting the installing the measuring equipment and observing the all the data means it's a time taking process. That means you want to observe the data 1 year, then only we can start the implementation. For the PV watt, it having the different data sets, database. That means based on the latitude, longitude, it having the lot of the data. If you based on the longitude, latitude, you can pick the data, you can get the some accurate data. Based on that data, you can simulate your system. PV system also is that type of uh, calculations only. What is the difference between this one, these two means, and the previous one is it is following the own data only. The PV watts is following the own data. The PV system you can manipulate the data. That means you feel that data is not accurate. That data is having some error means you can change it and you can simulate that. That is that provision is available in the PV system models and the window grapher model. The window grapher tools is especially for the wind turbine simulations. The analyzing of the complete wind turbines. The what is the performance and the power versus speed curve. Okay, that catchment areas, weight of that attitude. That means the height of the hub. So related the factors to the towards the wind turbine based power generations, we can use it with the window grapher tools. Window Pro also that type of simulations only. The Window Pro and Window Grapher is especially for the wind turbine um, simulations. Then Red Screen we can see. The Red Screen is a energy management platform. It's not only the wind, not only the solar, the energy in the sense we need the lightning energy, we need the heating energies, we need the cooling energies, and we need the temperature. That means the thermal energies. Okay, so what type of energy is need? All the type you can integrate it here. So what type of energy generation is possible? All the type you can integrate it here. So energy generation, energy in the current form. That means as it is a chemical energies or wind energies. So as it is, we need some simulation means we can go for the red screen software. At the same time, the red screen, with the additional of this all those things, it providing the planning of the complete energy system and the monitoring of the complete energy system and the reporting of the complete energy system. The system simulation is one of the barrier for us. After that, it having the long sight of the report development plan. So these are another barriers. This is generally is a designer facing these issues. They may construct if you they take it as some tools that they construct some models and simulate on the day. Okay, if you next day some resource value changes means they want to change the all the data as it is. Then only the exact output you can see. But the red screen is not like that. If you choose your latitude, longitude on the particular area, today you see some values. If after 1 month the resource values changes means automatically input, that means input data also revise it. So and when you are seeing the output, that is the on the particular day output is based on the input values. And the helioscope, RE opt. So this is also one of the energy simulation tools. So in these presentations, we mainly discuss about the Homer, HOMER, hybrid optimization model for electric renewables. This is also introduced by the NREL only. Why I choose this one means because the uh, interested for the hybrid renewable energy system. So which tools having that provisions means in these tools only. So here the green indications and the red indication is there. So maximum green indication is the additional provision of that software. So that tools only we are going to discuss in this um, session, mainly for the advanced tools. Some more tools also you can see the gate cycle and regional energy development system models, energy plant tools is there, commode tools also is there. So here some of the tools only used for the performance analysis, some of the tools is using for the only economic analysis. So very few tools only available for the performance as well as the economic concerns. So what are that means is a Homer is possible, red screen is possible, and SAM is possible. If you the research oriented point of view, you need one tools to simulate the renewable energies means you can choose the SAM, Rescreen, and Homer as your primary tool to analyze the both performance as well as the economic constraints of our system. Yes. So Homer is the we prepare the Homer. Why? Because it's having the many provisions with that. Technical performance is possible, economical performance also possible. We can add it the solar system, we can add it the wind systems and the battery. Okay, so what are the components? Are all the component is have it. Okay, so with the help of the Homer, we can design one village power. We can design one standalone power, standalone systems. Grid connector system also possible. Conventional technology, conventional energy generation also possible with the Homer system. Any new technologies. If you flywheel technology is there, compressed air storage system is available. This similarly, it's a pumped hydro system also available. It's having some simulation model. That model is also available in the Homer. The initial version is a Homer. Now the Homer Pro is available. Homer Pro is the every month you can see some updations. According that, the current version is nearly is 14 something is available. It's looking like a Homer Pro. Then, what is the main intention of this Homer software? The Homer software, it's recommending some combinations, the best combinations to meet our demand with the reasonable cost with the effective performance. So that type of that is our objective. Generally, that is our objective. That objective we can easily simulate and we can easily find out with these tools. Then technologies. The Homer having the provisions to simulate the solar itself, to simulate the wind itself, and the combinations of these two. If you any more additional sources is need. That means single technology also you can simulate and multiple technology also you can simulate. If your single technologies means is that constraints are limited one. It's a multiple technology means the constraints is a many. So all the constraints you should consider. If you, for example, if a microgrid design, two things is a primary components. One is the maximum energy we need. That means that system want to generate the yield energy. That means how much ceiling energy is possible. That energy want to produce. That is one thing. That is generally is a optimization function. Correct. That function is the maximize of functions. If you that system, the another objective function of that system is the it include the minimum cost. That means a cost minimization function. So if the function is having only maximize means is easy. The functions only minimize function, that is also design is easy. If the function having the maximize function or the minimize function, you want to make it to the optimization among that means it's a complicated thing. Okay, so that thing the homework can fulfill easily. So that is the peculiar thing about this homework pro software. And apart from this, different type of generators we can use it. Fossil fuel generators, that means our petrol based, diesel based gensets, biomass based genset. If your system is need the co-fire, if a system is the co-generations, so what are the combinations available in the fossil fuel and natural fuels? So all the configuration we can use it in these tools. So here, what are the fossil fuels are available? All the fossil fuels are, we can pick it directly. At the same time, the fossil fuel inherent characteristics also it can incorporate with our simulation systems. Okay, if it generally is a biogas is a diesel, is a calorific value will differ. Okay, if you no need for this calorific value and searching the articles and what is the exact value for biogas when burning the one kilogram of biogas, how much calorific we can get it, and the diesel means how much calorific we can get it, because the calorific values is the raw quantity of the our energy generation parameters. So based on the calorific value only, how much energy we can generate, that prediction is possible. Okay, so that link, that basic information you can get it directly from this tools. Then grid extension. Is a standalone system economical or the grid connectivity system economic? So standalone system economic means what what are the things is necessary, and the grid connected system means what are the things is necessary. The standalone system and the grid connected systems, it is giving the information to the investor related to the decision making. Is that system, if you, because the energy as a this forums as a peoples of electrical engineers is the energy generation and utilization is one of the business. Okay, in that business, so what is the, which one is accurate, which one is a more investment, which one is a less investment, with the payback period, which one? So many economic related constraints we should consider. Okay, so that point of view many decisions needed. So in that time, the standalone system and the grid connected system, that comparisons we need. So that is also we can make it easily with these tools. Like compared to the standalone systems and break-even grid extension systems, distance. That means if you, for example, here I shown one diagram. In the diagrams is the that orange lines is indicating the standalone system. The standalone system, it is the constant NPCD having. If a grid extension system you see up to the 1.7, the grid extension is incurring the less cost. After that only is a high cost. So here that investor, he can take the decision what is the grid extension system. That means grid extension distance. According that he can fix the standalone system is superior or grid extension system is superior. So according that he can install, he can enjoy the renewable resources based generation. Then if a grid connected system, standalone system means it is the completely that characteristics is isolated. That means if you power generation is there means your load will operate. Power generation is not there means your battery backup will support a certain time. After that, your load will the shut down based on the backup duration. You are fixed with that. If it's a grid connected system means our challenges to be rising next level. And that means grid connected system, um, standalone system, that combination, that means we have the grid integrations as well as the that means renewable resources integration also. So one is from the conventional, one is from the renewables. So can we uh, take the decision, fix the grid contribute is some fixed values. That means 1 year I want to use the up to 1,000 unit only. After 1,000 unit, I won't depend on the grid. So that type of constraints you may fix it. Otherwise, I need the grid continuity for just backup purpose only. So what are the energy I need? All the energy I'm trying to get from the solar or PV. Okay, so that type of constraints also possible. So in this case, grid energy and PV energies, both the characteristics differ. That means the grid can get it the continuously. PV, you can get it in the daytime only. Nighttime is not possible. So at the same time, is a solar system need the backup, all those things. Okay, so in this time, what is the rate schedule of the grid powers? What is the net metering constraints? What is the purchasing you are expecting every year? What are the injecting you are promised to that EV grid? So this is a policy making. Okay, so that thing also possible to see here. So in the microgrid, many challenges when the entering to the design concept, I say each and every point we should take some decisions. All the decisions that having the solutions means is easy. So that provisions is available in this Homer software. That's why based on this Homer software, you can easily simulate your system is the effective manner. And the demand charges, the demand charges is depends on the your maximum demand on that particular day. Okay, so you feel it either you want to cut down the demand means you can fix it the great demand in the flat scale, and whenever the existing demand is that demand you can fulfill with the solar and your backup systems. So that provisions, that mean demand charges indications also we can use it here. Renewable technologies, solar we can incorporate, wind we can incorporate, biomass we can incorporate, hydro we can incorporate. Okay, so what are the wind resources is possible? That means what are the renewable resources possible? All the resources you can add it here. Emerging technology, that means advanced technology simulation also possible to here through the Homer software. Fuel cell, micro turbines, small modular biomass. Small modular biomass means it is the one of the emergency genset type of the arrangements. So nowadays the biomass based plants, that means a miniature biomass based plant, it's available in the 2.5 lakh itself. We can take it as a ready-made. If that is also connected with your energization system means electrification system means how the performance you may check it. So how much biomass is necessary for this particular month? How much energy I can expect from this biomass genset, and micro turbines, which type of micro turbine we can use it. And micro turbine in the sense is the vertical wind turbines. Is you see the horizontal windmills is a very huge windmills. It's a megawatt generation is possible. Okay, if a micro turbines is start from the 250 watts to uh, 2 kilowatts also possible. So you can install this type of turbines, wind turbines in your elevation, the front buildings, front building top also. So due to the building height, automatically you can get it the uninterrupted wind speed. So based on that is a chance to get it the some minimum energy generation. That energy generation you can use it for your daily usages. So that type of advanced emerging technologies also you can simulate with the help of this Homer Pro Tools. Done. If you Homer, you can use this Homer means what are the issues, what are the decision questions I'm express in the starting of this Homer Pro slides. The all the question, you get the answer. That means the sizing you can know. Is that the sizing is able to meet our demand or not? That is also you can decide. And what is a battery bank? What is a battery bank and what is the anatomy for everything? You can know that. And the fuel price also changes. The fuel price changes means how my system sensitivity will change. That is also we can know it. And how you can plan to operate your system. That is also you can able to know. Now, homework tools we found, and that tools is very supportive to the simulate one integration of the hybrid renewable energy system. That the system you want to incorporate your simulation means what are the steps you want to handle. That means is the approach to that homework tool simulations. So there is a three stages is we want identified here. One is the assessment stage, another one is a simulation stage, and the evaluation stage. The assessment stage means is related to the site, is related to the energy availability, is related to the resource availability. Okay, in that particular site, it is having the capable or not. Okay, and what is your demand? That means the consumer demand assessment or a resource assessment, energy mix technology assessment. So this is a pre-assessment. If you done this assessment means based on this assessment values, you can run your, you can construct your hybrid renewable energy model. That means Homer model. If you once you construct the Homer model means optimization analysis we can do, and sensitivity analysis we can do it. Optimization analysis means um, it will give the recommendation of the many configuration. When the solar is 1 kilowatt, wind is the 1 unit, battery is the 10 numbers, what is the cost, what is the energy generations. When the wind you taken as a 2, solar is taken as a 3. Okay, so different such space values. That means that such space is your constraints only. I have this much amount of capital. I may choose the up to 500 kilowatt of the solar panel. Okay, I can go for the 2 number of the wind turbine. So this is a user constraints. Okay, when the 1 kilowatt of solar panel and in that time, what is a techno-economic performance? Okay, when the 2 configuration, what is the techno-economic performance? It is a optimal analysis category. Okay, after that, the sensitivity analysis means today my wind speed, I feel it as a 3 meter per second. Okay, 3 meter per second today wind speed happen. So what is the energy I can expect from the wind turbine? So that is one of the analysis. Is a tomorrow maybe that energy is it's raised to the 1 more meter per second. That means 4 meter per second. If the availability of wind speed is 4 meter per second means how much energy I can expect from the system. That is called sensitivity analysis. So optimization analysis is possible, sensitivity analysis is possible. If we optimization analysis result and sensitivity analysis results, we want to evaluate our system, which one is suitable, which one is highly fitted to our system. Okay, so first one is a technical performance. From the technical performance, sizing of the components we can understand, total unit of the generation from the system we can get it, and the renewable fraction values also we can get it. The excess electricity generation we can get it. That means these are the measuring indexes. Sizing of the component, total unit generation, renewable fractions, and excess energy. So based on this performance indexes, we can conclude the technical performance of that particular system. If we coming to the next point is economical performance indexes. What are that means? Is a NPC is there, net present cost. COE is there, cost of electricity. Annual cost is there, and the cash flow of the system is there. If you know this index parameters means we can take the decision related to the economical nature in easily. So that is our evaluation. Then environmental performance. If you this configuration, how much energy we can get it? It's a help to how much carbon emission to avoid. So GHG emission how much possible? Okay, from this GHG emission, how much carbon credit we can get it or not, we can attain or not. If you this all these evaluations based on the thermal power plant, that means conventional energy only. If you 1 unit generation from the thermal power plant, how much pollution is coming? That same 1 unit we are getting from the um, our renewable resources means that pollution is avoided. So that is a credit for us. That is called carbon credit. So that performance also we can evaluate. So any microgrid designs, these three stages are important: pre-assessment stage, simulation stage, and the evaluation stage. In our case study also, we'll follow the same approach here. Then system tools is ready. Our simulation tools is ready. After that, um, our methodology also ready. So now we want to construct our objective function of our system. So what are the objective function we are expecting? That objective function is a maximized function or minimized function. Why? Because the hybrid system is a multi-objective function simulation. It having the maximized function as well as minimized function. So both function you should consider. So our objective is the multiples. So based on the multiples means is a weightage based, we can fix the system. We can select our system for the next level of the implementation. So investment cost to be minimized, maintenance cost to be minimized, annualized fuel cost to be minimized, CO2 emission to the minimize, unmet load condition to be minimized. Unmet load means continuous power supply we are expecting. Maybe resource unavailability, our oversizing, irrelevant range, maybe certain time period of the disturbance we may accept. That means a tolerance level. That is also it's one of the minimized function we are fixed here. What are the maximized function we can use it here? Continuity power supply, energy generations, financial viabilities, and renewable fractions. So these are the maximized function. So first, this constraints fixed by the users. After that, based on these constraints, we can develop the Homer model. From the models, we can understand the system optimization techniques. Yes. So these are the expectations. Constraints are always expectations from the designer side. Is a simulations. It is need for the every year, every hour of the year is possible, or every month of the year is possible. If every hour of the year means is the micro analysis. Every minute of means is the very nano analysis. You know that forecasting, the short term forecasting, medium time forecasting, and the long term forecasting. Okay, so here it is one type of short term forecasting because energy is a precious. That energy is only is important to the operate our daily routine life. Okay, today my energy demand how much, tomorrow my energy demand how much, next hour my energy demand how much, next hour my demand is this much, my system can capable to meet our demand or not. Okay, if you feel that system is not meet out means you can take the some other immediate actions, some of backup actions. So the complete hours of the year we need to simulate. Okay, from the complete hour simulate, we can pick the optimized result. That optimized result means maybe based on the cost wise, maybe the based on the performance wise. Generally, this optimization is a developed countries. Developed countries in the sense is a updated countries. Those are the well known about the concept and well known about the precious of the energy means. Their first preference is the performance only. The performance means if you battery energy storage system, it's taking the too much loss. That means the cycle loss is high. Okay. Any other energy storage system having the less cycle charging means they prefer for that. That means they need the completely is a optimized performance without any certifications. They always depends on that complete performance. If you some of the countries, in our natures, we are depending on the economically dominated performance only, economical dominated system only. That means always we are thinking about the NPC. So developed countries, they concentrating the cost only, the net present cost based optimization result. Then sensitivity analysis based, they can go for the next level of the implementation. Any addition is possible. What is the marginal cost? If you variation is happening, the fuel prices means how the system will develop it. Wind speed changes means how the system will develop it. So that all those things are sensitivity analysis. So these are the main things. So simulations and optimization and the sensitivity analysis. All these parameters we want to implement the step by step. First, to complete the complete year of our simulations. From that year of our simulation result, we want to find out the optimized configuration. From the optimized configuration, that input changes means how that optimization configuration behavior will change. That is also we should understand. So that is the main challenges. Generally, one microgrid designer will face it. So according that, we will approach our system also as the solution for that. So here, one of the schematic diagram for the how we can see these issues. Take the resources, resources availability we want to do it, and energy generation pairs technologies we are doing it. We are find we should find it. After that, based on the technologies, component component we want to select it, and each component search space we want to fix it. That is a user constraints. After that, if you each equipment cost, each equipment replacement cost, each equipment operating cost, each equipment resources waste energy generation characteristics. Okay, that means input and output characteristics. So all those things we want to incorporate with our objective functions. Okay, once the objective functions happen means we want to follow any optimization techniques, maybe the artificial techniques or is intelligent techniques. Okay, so any technique, that means optimization only concept here. Okay, the recently the optimization techniques is a you may go for the PSO techniques and the genetic algorithm techniques. Simulation annealing technique is there, and ANF, neural network based techniques also available. So any techniques which one is familiar, we can incorporate there and find out the optimized objective functions values. From that objective values, we want to evaluate all the result, which one is suitable to incorporate with our system. If you after optimizations, you can get it this type of performance only. That means based on our objective functions, the objective function wise dominated result we can see it. Okay, now you can fix the user constraint, your consumer constraints here. So what are the possibilities? All the possibility we are developed now. In this point, you can implement the user constraints. My cost is this much only, my budget is this much only, which system is preferable? Okay, this system having this much drawback, that means this system having the COE, the cost of energy is very high. Okay, can we prepare for that? Otherwise, the solar contribution is very less here, wind contribution is very high here. Can we increase the solar contributions? My backup time, I want this much hour is needed. So what are the decision related constraints you have? All the constraint you can fix it, find out the best solution or best configuration as per your constraint, you can pick it. Okay, so now this tools, that means the homework tools, I make it one case study. This case study is a health clinic, um, one temporary clinic. The temporary clinic, what are the energies needed? That energies we are trying to get it from the solar panel and the diesel generators with utility power grid. Actually, this case study is done in the COVID durations. That means is in that time is many temporary clinics are developed in the all over countries. So in that time, If a particular area it has this much solar, it have due to this distance, they can government can provide this much amount of the fossil fuels. This much time only the energy generation is possible. That means grid power supply is possible. Okay, so that type of situation, the microgrid we are constructed means how the effectiveness is there, what is the investment is needed, and how much energy we can generate it. So all the technical and economical related analysis we are done in that health power clinics. So here resource is the photovoltaic array, diesel generator, and utility grid system and battery. So resources point of view, solar is a renewable, and diesel is a conventional, and utility grid is our regular grid terminal system. So here integration is possible, correct? So solar is there, and diesel is there, and the grid is there. So integration is there. This is a hybrid renewable energy system. One is a solar, and the backup is the battery. So this is one of the hybrid renewable energy system. So first thing, location and the time of the zone. Where is the location? In that location, what is the wind potential is possible? What is the solar potential is possible? The solar potential we measure with the irradiations. Irradiation means is the kilowatt per meter square per day, how much irradiation available. For example, in Hyderabad, in my locations, the Vardhaman College, we are getting the solar irradiation is of 5.3 uh, kilowatt per meter square per day is possible. What is the clearness index on this particular area means it is the 4. 4 is a clearness index. That means if your sunrise is started from um, the above that, all the sunrise is reached to ground or not to my panel. So that is called clearness index. All is reached to my panel means that is index is 1. Clearness index is 1. If you not all is a 5% only reaches means is a 5. That means 5. Okay, so that is the induction here. What is the clearness index? Based on that, our efficiency of the power generation is different. And the financial assumptions, solar panel cost, what is that? What is the lifespan of the solar panel? What is the replacement cost, operational cost? If you 1 liter diesel, so what is the price of here? Okay, that genset cost investment how much? Batteries cost how much? If a replacement cost. So each and every component cost we should know. What is the market values for the each component? The power assumption. The power assumption means how much power is needed. That is the day profile of our loads, electric loads. If you first, these are the pre-assessment. Based on this, all the free assessment data, we fix our areas, the longitude and latitude we can fix it. So Homer software can fix the based on the longitude latitudes, what is a solar radiations, what is a wind speed, everything it can pick it from the NASA database. Not a NASA database also you can pick it. Otherwise, the NREL, that means who's introduced this software to the world, and they also maintaining some database. From the database also, we can pick our the resource availability on the particular site. If you once the particular site is located means after that load calculation is needed. So if you we are planning for this is for one health clinic, that means a temporary health clinic. So what are the equipment might be they using? Refrigerators, vaccine refrigerators, non-medicines, okay, and the centrifugal pump them and some pump purpose they're using. Okay, so each and every component, how many quantities, what is the power consumption, what's the total wattages, and when they using the duration of the working hours. So this is the using for the load profile development. So daily load profile we want to develop it. Okay, if you know this daily load profile mean that load profile can meet out our demand, meet out with our resources or not. So that thing we are going to analyze. This is the load demand analysis. Now you are implementing strategies. That means next strategy that's Homer tools you are incorporated means If you first see one result, you can see that is a configuration, and Gen 50 means it is a gen set 1 kilowatt of the lithium battery. That means here genset and lithium battery. When only this source is available, okay. So PV is a 0, generator is a 5 kilowatt of generators, grid also 0, battery is a 8 numbers we are using, converter is a 5 kilowatt equivalent of converters. So in this configurations means the capital cost this much dollars, $7850. What is the net present cost of this one means this much, 1334.64 dollars. What is a COE? That means 1 unit of energy means is a 0.71 dollars. How much fuel is required? 3957.1 liters. Generator operating hours 2748 hours. Okay, if we going for the next configuration, that means genset, PV, and battery. Okay, so the cost is rising. Then going for the next configuration, only genset cost is rising. Only genset PV, what is the cost? So these are the different configurations can meet your demand uninterruptedly. Okay, so this configuration then use your constraints. Which configuration is best for us? If you generally is a fuel price only, is a best fuel price only, based only the scrutiny is happen here. Why? Because the genset is means fuel price only. That means how minimized energy we are attaining from the genset, that is a preferable. Otherwise, how maximize energy we are attaining from the PV, that is a preferable. So here we can pick it and we can analyze it, and what is the cost, everything we can understand. See here, PV 1 kilowatt is needed, generator is a 50 kilowatt is needed, battery 8 quantities, and converters 5 kilowatt converter. We can follow the cycle charging strategies. Cycle charging strategy means we should ensure our battery SOC first, then meet out our demand. Okay, so in this the architecture, this is a microgrid architectures we are attained from the Homer Pro tools. Then what is the cost? Capital wise, what is the cost we are incurred? What is the fuel wise? What is the cost it takes? Operating cost how much? Replacement cost how much? Then each component wise also we can see. That means is the green is indicating genset related cost. This orange is indicating the lithium ion battery related cost. Then generic plate cost and converter cost. So each component NPC, each type of cost wise NPC also we can split it here. If this economic factor is helping to the investor to choose the best configuration as his desire. So how that cost flow in this system? What is the initial year investment, next year investment, up to the 25-year investment? Actually, here we are assumed as our microgrid system, the lifespan is at 25 years. So here this yellow is indicating for the fuels, genset fuels. The green is indicating the replacement cost. Capital investment is the orange color, then operating. So the salvage is one of the additional costs, additional information we can get it from. Actually, it's a 25 years the lifespan of the project, but each component wise the lifespan is a different. Maybe the battery is every 5th year we may replace it. If you operating hours for the genset, every 500 hours we can replace it. Okay, that type of each component lifespan is different. If after 25 years, okay, any additional work it have, it is capable to use some component for the power generation means that is the salvage cost. So here the battery charging, battery state of charge. This is a day map. When is a high energy we are using, when is a low energy we are using, and what is a day hours. So each and every month, each and every hour, we can predict the our state of battery state of charge. So this color, where is a concentration based color, that values we can fix it here. Then this system, we choose one system, that system having the part of the our diesel genset. It's a part of the our conventional grid. So how much carbon it will emit to the atmosphere means it is a 10,420 kg per year it can emit as a carbon dioxide, and the carbon monoxide is a 26 kg per year. Unburned hydrocarbon 3 kgs per year. So similarly is a that matters the some others matter, that means unburned hydrocarbon, some that means sedimented matters, that is a 2 kg per year. Sulfur dioxide is a 21 kg per year. Nitrogen dioxide is a 230 kg per year. So before that we see about the one health clinic case studies. Next we will see about the one village power case studies. Village power case study means next higher level. Because in the previous case, the total demand itself within the total demand is a previous case within the 5 unit per day. The village means is coming to the 100 units per day. Otherwise, it comes to the some megawatts, 1 megawatt up to the 1 megawatt per day also possible. So in this case, what is the process we should follow? So first we want to take it the total power generation. Is one of the process is same. Just I'm explaining the only objective functions here. We want to develop the energies. That energy is the P total. It's a part of the solar PV, part of the wind, part of the biomass. So what is my plan? One village. That village is having some energy demand. That demand I am trying to meet out with the solar PV, wind, and biogas. Okay, so what is that cost minimize function? This one, that means each unit each plant, that means power generations. What is a power we can attain? What is the cost of that? That cost is going to less. Okay, so the system want our simulation algorithm to suggest the configuration which one is takes minimum energy investment cost. See, these are the information about the additional cost, the annualized cost expression, annualized capital cost expression, operation cost expressions, annualized replacement cost expression. This all the cost is related to the CRF. That means a capital recovery factor. The capital recovery factor is an important parameter to decide our annualized cost, operational cost, and the replacement cost. Because the annual cost should be the minimum, so that parameters consist of the capital, fuel, and the replacement. So this is another objective function. This is the minimized function we are expecting from our simulation. These are the constraints, different operation strategies constraints. When my system want to inject the power to the EB grid, when the system it want to take the grid power supply, when is the load priority we want to give it, when is the storage system backup we want to ensure. If you want, this constraints help to the uh, design or operating our system. For example, in the EB electricity board, we can get it the flat scale tariff. That means evening whatever anytime we are using the common rupees only we can pay it. So in our nation, but abroad nation, that is the time of use tariff. It's a peak time, one unit consumption means more amount we can bear it, and off peak time means it's a less energy we want to bear it. Okay, so here according that we can fix it the that tariff. If you get it the energy from the more amount and store it your battery is not a logical. That means you want to bear the system it's incur the more amount. So whenever the EB supply, that means electricity board supply is less, In that time only I want to charge my battery. Like that, you can fix it the constraints as your defense. Okay, so these are the constraints I'm using when the solar PV biogas based power generation system. Now, these are the optimization techniques I can use it here. So here, ANN based, that means artificial neural network based optimization technique I'm using. Okay, so based on the ANN, the load prediction and resource prediction I can done. Based on these values, the Homer optimization tools, solar and wind resources data and objective function details are incorporated, and the system constraints also incorporated. Then economic dispatch strategies incorporated end. Finally, the optimized result we are attained based on the investment based constraints. So what are the constraints? We want to implement the step by step to develop the hybrid optimization configurations. This approach also we can use it. So before cases, the prediction done is the one first phase, then optimization second phase. Here, the simple Homer approach, that means pre-assessment stage, Homer analysis stage, and fast Homer, that means post Homer, the evaluation stage. So this is exactly it's suitable for the Homer based simulation. So do the site analysis, take the site assessment data and incorporate with the simulation tools. From the tools, you can get the some output, that analyze that output in the performance wise, analyze the output in the uh, economical wise, and finish your system. See, if in that village, based on the resource availability, these are the possible constraints is possible. So performance rank also is there. This rank is developed based on the NPC. Which one is having the lowest net present cost? It's coming first. So 50 kilowatt of solar panel, number of turbines, biogasifiers. The biogasifier means the biomass plant, and how many batteries is needed, what is the converter size, what is the total cost. This is the performance ranking for the different HRE configuration. This is the before case. Yes, and this is economic ranking. The before one is a performance ranking. Uh, this is a performance ranking, that means sizing and it's a economic parameters. This is economic nature in the different configurations. What is a COE? What is the operating cost? What is a renewable fraction? Renewable fraction one means all the energy we are attaining from the renewable resources. If your renewable energy is some fraction values means so some of the energies we will not get it from the renewables. It is a conventional base. So this is the different dispatch strategy. I said the cycle charging strategies and load following strategies there. So cycle charging strategies means each component how much cost it takes. The converter how much cost, battery bank how much cost. So like that we are splitted here. So the outer circle is indicating the load following strategies. Inner circle is indicating the cycle charging strategies. So cycle charging and load following strategies both is a differ. Why? Because it's based on the lifespan, based on the anatomy natures of our backup, the cost values will rise. So according that, the each cost in each component cost also will vary. So this is a cycle charging strategies and load following strategies different in the point of the economic parameter, in the point of the um, performance parameters. If you see the size cycle charging strategies, um, PVDC powers is a 83413 is a load following strategy 16686. So here itself some information we can get it. Load following strategies means energy generations directly using our load. The cycle charging strategies means energy generate, store your batteries, ensure your battery capacity, then use it for the load. So storing the charge, storing the batteries and usage your loads means it is the additional sizing is needed. Okay, so that's why it's developing this much amount of the energy. Then total generation you can see excess energy, excess electricity is very high in the cycle charging. Excess electricity is very low in the load following strategies. Fuel consumption, it's required the 500 liters in the cycle charging strategy. Its load following strategies 550 liters is enough. So here the cycle charging strategies, load following strategies having the own pros and cons. So again, we want to implement the constraints of the user, constraints of the availability of the system. We can pick it the best system here. Yes. Here our load, the AC load, as well as the PV and wind demand expression we can see. At any time period, AC load should be metered by PV power or wind power. Okay, any difference is there. That means in the particular hours, any deviation is there. It's not mismatch with our load with respect of the summation of the solar and wind means remainings we are getting from the conventional or battery. Okay, so the complete year, complete hour simulation is possible in these tools. So this is battery performance, which is a load demand. When is the battery to be charged? When is the battery to be discharged? Okay, so AC load is indicating in this blue color. Battery power supply, it is the indicating the black colors, and the power, excess power. That means the excess power means the system can able to generate power, but we can't store it and we can't utilize also. That is called the excess power. So based on the excess power, the additional load increment you can decide. Otherwise, um, additional policy agreement with the grid injection also we can make it. So we're not having that power either storage or either usage. So in that case, what we do? We can either inject, otherwise we can increase our load in the next phase of the implementation. So like that, the decision we can take it. This is a great break-even grid extension distance, standalone system and microgrid system. And that means the system it's effective in the 72 kilometers. That means up to 72 kilometers, grid extension system is economic. After 72 system, it's a standalone system is economical. So like that, uh, we can use the advanced simulation tools for microgrid design. So in addition of this theme of this workshop, the converter design, that means advanced power electron converters, And the converter charging, converter efficiency is one of the parameters. Generally, we are designing our converter for the requirement of the power system. Somewhere is a constant parameters we want to maintain, somewhat efficiency of the converter you want to increase it. Okay, so where we can incorporate this converter parameter with this homer mean, that option also available. Generally, the converter efficiency is decided by the designer. Whether my converter is a 95% efficiency, is a dual converter. Okay, is a inverting time is a 95, converting time is a 85. Like that is a different cycle of mode that the efficiency will change. That you can decide here as your converter design. First do the conversion part, then what is the efficiency you can fix it. That efficiency you can feed it in your Homer software as the field. That field is available. Okay, at the same time, the converter cost, converter replacement cost, converter performance. Okay, so that is also we can add it here. So in the microgrid design, what are the components we are using, what is the cost of that, what is the parameters, what is the characteristics, everything we know it, we can feed it with this Homer software. Actually, the Homer is nothing but it is one of the simple calculator. It consists of the many modeling design that parameters you only feeding. If that parameters exactly as the reasonable values means it will show the accurate result, exact result. Otherwise, it show the wrong result. So in the second one is the village design. So I choose the one of the village is the Pondicherry regions. In that village, it's a demand is available. That is total village demand. Okay, so that demand I want to meet out with the solar, wind turbine, and biogenerate backup only. Biogenerator and battery backup. So in this configuration, 1 unit of the cost, that means 1 unit from this configuration, we take the 8.231 kilowatt per hour. So it's almost reasonable. Why? Because the conventional grid without subsidy, okay, it's a unit cost is a 9 rupees. So when going for this configurations, it is a 8.2 only. So it is a lesser than the our utility power sub utility tariff. So that's why that village we are recommended for this configuration to meet out the demand is continuously with the lower economic parameters with the higher performance. So this is a conclusion. Mm, with the extension, that means this work you can make it as a publication purpose also. In the publication purpose, you can show your novelty in the prediction purpose. That means load growth and load predictions and uncertainty handling techniques. There you can incorporate any new techniques, and that technique with the Homer simulation techniques, it become the um, good publications. It make it good publications possible. So here, ANFIS tools also we can use it for the load determinations. That means the prediction of the load, because based on the load only your generator you are designing. So that prediction of load is not accurate means your generation also not accurate. So first predict your load exactly. According that you can fix your parameters. That is one technique here. Then AI techniques, the machine learning techniques also we can use it to find out the performance, the optimization performance, or find out the prediction values. Okay, so with this, I am concluding this presentation. If you have any doubts, you can ask now. So these are the references. Yes, thank you. Any doubt you can ask now.
Thank you, sir, for sharing your thoughts on RES and how a microgrid is designed using the advanced simulation tools. And you have clearly explained the RES in attaining the electricity demands, and also you have clearly explained the tools in home, like how to use it in the Homer. And also you have given the great idea for the upcoming researchers. Thank you, sir.
Thank you, ma'am.
Now
Thank you, ma'am.
time for queries. if participants, if you are having any queries, you can unmute yourself and you can clear your doubts.
Good morning, sir.
Yeah, good morning, sir.
Sir, this is Manohar from CVR College of Engineering,
Yes, sir. Yes, sir.
Hyderabad. Sir, you have explained about Homer Pro and other softwares. I have the small
Yeah.
doubt. So when in
Yes, sir.
interconnected system, so can we perform fault analysis also? In suppose I have a fault and wind turbine, it is interconnected to solar and co-generation. It is there.
Yes, sir. Yes, sir. Yes, sir.
So in case of dead short
Fault
circuits,
analysis.
yes, fault analysis.
Yes, yes, sir. Fault analysis is not possible in this because this is for performance, sir. Complete performance as well as the economical performance.
Okay.
Fault analysis means is a my power you can use it, sir.
Okay.
My power, this option is there. That means is a fault analysis and your surge analysis plus and that is the each and every time period any spark, and that means voltage deviations.
Yes.
Actually, load flow. We are asking the load flow. Exactly correct, sir.
Not
Load
exactly
flow also
load flow,
possible.
sir. In case of
Hmm.
faults, actually, how the system reacts for different controllers like that.
Yeah, that is my power only possible, sir.
Okay. Currently, we are
In this
working
what
under MATLAB. So maybe other software.
MATLAB is the open. That means you can develop the that is what is soft computing. Okay,
Yes, sir. Yes, sir.
coding you write it. Always pick some tools and make it. What are the tools we are discussing? All those things are hard computing. That means templates are available. You want to give the input and check the output. So that
Okay.
point of view, my power is doing that work. Fault analysis
Okay.
possible, load flow analysis possible. Still, you want to integrate with this means ETAP also possible, sir.
ETAP.
ETAP also possible. Good.
Okay. Okay.
Especially for technical and performance means what are the software we listed? That is the good, sir.
Okay. My power and ETAP.
Yeah, my power ETAP.
Okay. Thank you, sir. Thank you for
That
the
is the
information.
simulation tools is helping for your fault analysis as well as the load flow.
Okay. Sir. Okay. Sir.
Thank you.
Thank you very much, sir.
Thank you, sir. Yes, any more doubts?
Sir, tomorrow we have lunch. Okay. We will only these 6 members and everybody and
Any doubts from the participants?
No, madam.
Okay, then you can fill the feedback form and you can leave the session. The next session is going to start at 2 p.m.
Okay, ma'am. Thank you, ma'am. Any? Can I leave, ma'am? Okay, hopes no more doubts. Okay, thank you all. Thank you for your patience.